They've been making planes here in Broughton since the 1930s and were responsible for producing aviation classics such as the de Havilland Comet, the Mosquito and the Wellington Bomber. Today the tradition continues and over 5,000 people produce 1,000 wings every year for the Airbus A320 family of aircraft. There are two main factories, and this one, the East Factory, covers an area the size of 40 football pitches. This is where the Airbus wings begin. 17.5 metres long and each weighing 4 tonnes, they need to withstand the incredible stresses of flight, carry the weight of the engines and act as a fuel tank. Making them strong enough without exceeding their weight specification is a seriously tricky engineering challenge. The secret of their strength lies in an inner frame of 2 spars and 27 interconnecting ribs made from aluminium alloy. This framework is covered with a skin of aluminium alloy panels to form the basic structure. But for it to be fitted with the mechanical components, it now needs to be shifted across the factory. That requires some seriously heavy-duty lifting gear and plenty of care, because the slightest knock could ruin the 4-ton wing. With the wing safely delivered to the back of the production line, it's ready for fitting with the hydraulic system, pneumatics and electrical systems, flaps, spoilers and ailerons. Work done, it's ready for its final function test, carried out by skilled fitter John Davies.
This was the most important test of all, because this is the last test before it goes out of the door, you see, so obviously everything has to be right. If not, I'll find it and then it'll be sorted out.
Each component is tested in turn to ensure it's functioning properly. Once satisfied there are no leaks in the hydraulic systems, just 2 weeks after it started manufacture, the wing gets John's stamp of approval and is good to go. But go where? This is where things get tricky, because the rest of the plane is being assembled 1,000 kilometers away in Germany. Shifting the 17.5-meter 4-ton wings by land would be impossible. The only option is by air. And for that, you need one of these. This is the Airbus A300-600 Super Transporter, or beluga. Named after a species of whale noted for its domed forehead, this custom-built monster looks about as aerodynamic as a block of flats and is arguably one of the ugliest craft ever to take to the skies. But while it might not win any prizes in an aircraft beauty pageant, when it comes to shifting vast cargoes, there's not much else that even comes close. As the huge dome opens, it reveals an enormous hold over 7 meters wide and almost 38 meters long. This 1,400 square meter deck allows the beluga to carry everything from the massive Airbus wings to entire sections of fuselage. But now the pressure's really on, because the wings are needed in Germany in just 3 hours' time. That means the ground staff have just 60 minutes to load the beluga, or the entire assembly line could grind to a halt. But of course they won't get far trying to shift 4-ton wings with a conventional forklift, so it's time to roll out another of Airbus's extraordinary toys. This huge 90-ton self-propelled lifter looks like it's come straight off the set of a science fiction movie. It can move loads of up to 50 tons. The only problem is it can be dangerous to operate in high winds. And with a stiff breeze picking up across the airfield, operator Russ can't afford to lose concentration.
Dangerous, just being aware of how close you need to be to the aircraft. Obviously when you're in the air, the wind speed, you're going to be wary of that because it does rock and roll a bit.
To make sure there are no expensive prangs, the lifter is fitted with a special safety camera system. This means that if Russ is just a centimetre or so offline, the lifter will immediately stop. Thanks to this incredible precision, the Beluga is crowned with not one, but 2 sets of wings. So far, so good. But with around 16 tons of wings in its stomach, it almost defies belief that the Beluga could ever get off the ground. But incredibly, the Beluga can muscle up to 47 tons into the sky. So the only problem for Captain Daniel Tremosa is the threat of strong winds.
We have a cruising speed a little bit lower than a normal Airbus, of course, due to the shape. And also, we don't like very much high turbulence and very big crosswind.
With the wind gradually picking up, Captain Tremosa will have to call on all his experience to get the bloated beast off the ground. But with a roar from the engines, just 15 minutes behind schedule, the Beluga rises from the tarmac and disappears into the grey skies on its 2-hour flight to Germany. Its destination is the Finkenwerder airfield on the outskirts of Hamburg. And thanks to strong tailwinds, the Beluga touches down early. Ready and waiting on the tarmac is another of Airbus's purpose-built lifters. And in just 45 minutes, they extract the wings from the hold and deliver them to the factory floor. The final assembly happens here in Hangar 9. On a floor area the size of half a dozen football pitches, 10,000 skilled workers assemble 180 of these massive kit aeroplanes every year. The reason they need such a vast space is they simultaneously piece together the sections of not 1, but 5 aircraft. Putting together an Airbus kit requires some serious manpower, and it takes some 400 people to keep all these jets rolling off the production line according to schedule. Despite the size of the hangar, it's essential every piece arrives for fitting bang on cue, or the factory floor will quickly become cluttered with unneeded sections. The jet's assembly is a model of European Union. First, the French-made nose and central fuselage is joined to the German-built front and aft fuselage. 3 days later, and they're then ready to fit the British-built wings and undercarriage. Ensuring this all happens according to schedule is Jan Vos.
Every station we got 3 days, not more, and you have to be finished after 3 days to move the aircraft to the next station.
To fix the wings to the main fuselage of this kit plane, you need more than just a tube of runny glue. The finished jet will weigh up to 64 tons, exerting a force on the wings during takeoff of over 100 tons. So, to make sure the wings are securely joined, they use almost 2,500 bolts. After 6 days, the wings are on, and the plane is fitted with the German-built vertical tailplane and the Spanish horizontal tailplane. While inside, interior fittings are installed and a number of early systems checks are made. Finally, the undercarriage is tested and the plane given a lick of shiny new paint. But before it's ready to take to the air, it lacks 2 vital components: the engines. Each of these engines weighs almost 2.5 tons and can generate up to 27,000 pounds of thrust at takeoff. At almost 4.5 million euros a pop, they're the single most expensive section of the entire plane. And the team needs to work in perfect unison to ensure they're maneuvered into position without being damaged. finally, just 12 days after the assembly began, this A319 is complete. But of course this is a brand new aircraft, and there's only one way to find out if it really is working exactly as it should. That, of course, is to take it for its maiden flight. So, on an overcast morning at Finkenwerder Airfield, pilot Jonathan Black and his crew arrive for what they hope will be an uneventful test flight.
It might sound exciting, but we don't really want excitement, we want it to be routine. In the ideal world, we make one first flight, and then the aircraft has no defects.
But however you look at it, testing a jet is always going to be a little more risky than testing a car. There are numerous complex systems on a modern passenger plane, and they all need to work perfectly. In charge of monitoring them is flight test engineer Andreas Balk.
The risk is that the systems have never operated in the real environmental conditions as they were supposed to do. So the risk is that something does not work as it should be, that we have to cope with it in real time. The weather conditions, you have checked the winds?
Yeah.
So
All
it
the
will
check is
be...
done, cabin's ready.
Okay, thank you.
Just a few weeks ago, this aircraft was little more than a collection of pieces spread out at 16 sites across Europe. Now, as it hurtles down the runway, the big question is, will they all hold together and work as expected? The answer, as if we ever doubted it, is of course they do.